Alright, so we're going to go through the practice preparation for the June 2012 Unit 3. It's a calculator paper, so have your calculators ready, have them there available for you. Can you make sure you've got them, please? As we go through, again, this is linked very closely to the skills that are going to be in this practice paper and in the correct order. So we'll go through and we'll do those. We're going to start off. The first question is going to be about similar shapes. Now, similar shapes are very simple once you know how they work. What we're going to do is... Can I steal someone's calculator, please? Awesome. Thank you. Okay. So, when we talk similar shapes, and the key word similar, what I'm talking about is I'm talking about two shapes that are exactly the same shape but different sizes. So what they've been is they've either been enlarged or they've been shrunk. So one of those two things. And when we do that, when we have the shapes that are exactly the same but different sizes, then we say that all their sides or all the lengths are in proportion. So I've got to try and find that link between the two. So it's really very simple actually. What I'm going to do is I'm going to find the two sides of the shape where I'm given both of those lengths. And for me, it's the base of each of these triangles. Now if I know the base of the triangles, one of them is 43.2. The bigger one's 43.2. I'm going to divide that by the smaller one, which is 8, the corresponding side, the same side, but different in the shape. I get 43.2 divided by 8. And what I end up with there is 5.4. What that means is that this shape is 5.4 times as big as the smaller shape. So all I can do then is I can then transfer that information back and forwards. So I can say that if this was 5 centimetres in the smaller one, then to become the length of the bigger side, I times it by 5.4. That's all. If it was a scale factor of 2, I'd double it. So in this case it's a scale factor of 5.4, so I times it by 5.4. So 5 times 5.4 gives me 27. So that's 27 centimetres. Easy. If I want to go from the big shape to the smaller shape, well, instead of timesing by 5.4, I divide by 5.4. That's the link between the two, so I continually use it, and I get 37.8 divided by 5.4, which is 7. So I get that is 7 centimetres. And that's similar shapes. It's that easy. What you want to make sure you do is you find this link between the two. Now, the one you're going to do in your test is actually a much easier question. The one that we're going to do in the test doesn't involve triangles, and it doesn't involve difficult numbers. It just involves some rectangles. And what you can see there is you can see that there's a link. I know the heights of each of those rectangles, so as long as I can find out what the link is, here, the big number divided by the small number, I'll then be able to find out what the scale difference is. And I'll be able to use that, and because I'm going to the big one, I'll times. When I'm coming away, I divide. Same as exchange rates, if you think about it. When we've got exchange rates, we times away from the unit and divide back. Well, for this, it works the same way. We times when we go to the bigger shape, and divide when we go to the smaller shape. That question there, just so you're aware, is worth 3 marks. So we're already looking at 3 marks for a simple skill of just being able to find the scale factor and then either timesing by that scale factor or dividing. Question 2, the second question, is actually about percentages. And in fact, the question on the exam isn't linking just with percentages, but it's linking with this idea of simple interest. There's 2 types of interest that we know about. There's compound interest, now that's the difficult skill. It's also called appreciation and depreciation, the same skill involved. And then there's simple interest. Now there's a key difference between compound interest and simple interest. Compound interest is where what we do is year on year we have to calculate what we've got. And year on year, you get an increase. So we sit here and we work out how much we have year one. We calculate the interest. And that tells us then how much we start off with in year two. We add it all together, we start off with that in year two, and then we do the whole calculation again. And we've done that before. Simple interest is a little bit easier. Simple interest is the second question on this exam, so it's not a B grade skill like compound interest, it's going to be a D grade skill, which in this case is really straightforward. What we have is we have year one, and then the interest that I get, I take away, so whatever the interest is, I take away, and I put, say, I don't know, in a box in my cupboard, or in a piggy bank. And so year two, I end up with the exact same amount as year one. So the amount of interest doesn't change. In fact, the difference between simple interest and compound interest is generally the mistake people make when they're asked to do a compound interest question. And they normally make the mistake of calculating the interest and then times it by 5, rather than recalculating year on year. So here, instead of writing that, I'm going to write the principal stays the same. So if I start off in year one with £500, I still have £500 in year two, and £500 in year three, and £500 in year four. But what I've done is I keep taking that interest, and I can either go and spend it or I can save it somewhere else. So I keep the principal the same. On top of that, you need to then know how to calculate the percentages of amounts. So what we get is, to calculate the percentage of amount is very easy. You know, we just do £28.76, and then on a calculator, we divide by 100 and times by 34. If I wanted to work out 76% of 900, we start with 900, we divide by 100, times by 76. That's it. That's how we calculate a percentage of amount on a calculator. £45.50 divided by 100 times by 12.5. That's how you calculate percentage. Now, this last question, just note, doesn't ask you just to work out 12.5%. It asks you to reduce by 12.5%. So you have one extra step in that. You'd have to then take away the value you calculated from the original, because you've been asked to do a separate step on that skill. But simple interest, so in this question, the exam question you're going to look at, there we go, it asked for simple interest calculation. So here, you work out 3%, and that's how much you have every single year, because the £500 isn't changing. I'm taking that 3% and doing something with it. So how many years does it take for that 3% to add up to £60? So if I work out 3% of 500, and then all I need to do is work out how many lots of that does it take to make £60. So that's the simple interest versus the more complicated one we've done previously of compound interest, or appreciation and depreciation. Don't lose marks on that, but that one there is worth another 3 marks for that particular question. The next question on the exam is a fractions question. Now, if you get a fractions question on this exam, you're the happiest person in the world. And the reason you're the happiest person in the world is because it's a calculator paper. So all you're going to need to be able to do is type that into a calculator. Now, to type that into a calculator, there's a button on your calculator. It looks like this. If you're a Casio natural display, then you have a key that looks like that. Above that key, if you were to use Shift, and then above this key is another one written like this. You want to use that to put in these more complicated fractions. So you use the button straight up if you want to put in, say, 2/3, or you want to put in 5/7. But if you want to put in 1 1/6, you need to use this one, because I need to be able to have a 1 1/6 put in there. So make sure you know how to use your calculator to do that. That being said, there's no reason this question wouldn't come up on a Unit 2 non-calculator paper. So I'm going to very quickly do a calculation. I'll do this one, question D. I'll do a division, because it's a division on the paper you're going to be practicing on. So I'm going to start off with 5 1/3 divided by 2 2/3. And I'm just going to quickly go through and do this skill for you. So first step is converting to improper fractions. 5 times 3 is 15, plus 1 is 16. 2 times 3 is 6, plus 2 is 8. So I've improper fractions. I then sit there and I never ever divide fractions. Instead I multiply by the reciprocal. So 16/3 times 3/8, so I flip that over by flipping the sign. And now I just do the multiplication. 3 times 16, or 3 times 10 is 30, 3 times 6 is 18. So I end up with 48. And 3 times 8 is 24. So 48 over 24. I'm then going to go through and I can simplify that. So I can halve it and get 24 over 12 and halve it again and get 12 over 6 and keep halving it. But actually, I'm going to look at that and I'm going to recognise straight away that 48 divided by 24 is just 2. That's it. That's how you divide by it. You won't always get a whole number answer like this, but you need to be able to go through and do that skill, both for addition and subtraction of fractions, and then separately for the multiplication and division of fractions. Remember, they're 2 separate skills. This paper, however, you get 2 marks to be able to type in your calculator and push equals, so make sure you can do that. The next question we've got it starts off, and I'm not going to bother going over this again with you because you should know how to calculate 20% of 650 pounds and then add it on because you've got a calculator, you can do that calculation. So I'm not going to worry about that, but that's 3 marks for doing that skill. I am going to focus on this idea of how to write one number as a fraction of, as a percentage of another. And then again, I'm not going to focus on part C of this because I'm expecting you to be able to do it. If 3 kitchen chairs cost £44.79, just work out how much 1 kitchen chair costs. And once you know how much one of them costs, times it by 8 to find out how many 8 cost. That's not really worth me spending time going through. That's 2 marks as well. This whole question's worth 7 marks, in fact. And the only bit I think you'd maybe get caught up on is this section B. So having a look at this, we're going to convert, using a calculator, each of these to a percentage. Now, to convert each of these to a percentage, what we do is we first of all write them as a fraction. So this is just here, 17 out of 67. And if I want to convert a fraction into a percentage, if I want it for 100, then all I do is I times that by 100. Now I type it exactly like that into my calculator. So I end up with 17 divided by 67, 17 over 67, times by 100. And in this case, I ended up with, to 1 decimal place, 25.4%. That's it. So 134, I've got 134 out of 386. I'll write it as 134 out of 386 times by 100. So I write the fraction in there. 134 over 386, and I times that by 100 to change to a percentage, which gives me 34.7%. It's that simple. 82 out of a possible 120, 82 over 120, and then times that answer by 100, or times a fraction by 100, and it'll give you a percentage. Again, this is one of those skills that could come up on a non-calculator paper, and if it comes up on a non-calculator paper, you do it slightly different, but actually no more difficult. So just quickly, I'll show you how to do it non-calculator style. Is if I was to get given a question, say like this, say 20 over 50. So I've got a score out of 20 out of 50. How do I convert that into a percentage? Well, I want it per 100. So you can see there, all I've done is I've doubled it, times it by 2. So I do the same to the top, which is 40%. 40 per 100. And I can do that for all of them. So I could do the same with, if I have, say for instance, I had 25. You can see, regardless of what goes on top, you can see that to change 25 into 100, I've times it by 4. So if this was 10 out of 25, times it by 4, becomes 40 out of 100. So again, 40%. Or we could do this, 200 over 100. You can see there that they go from 200 to 100, not timesing, I'm going to divide by 2, I'm going to half it. So in this case, if I had, say, 70 out of 200, then half of that would give me 35 out of 100, which is 35%. So you need to be able to write these percentages of amounts using both calculator methods and these simple non-calculator methods for these particular types of questions. But that's it, it's simple. So that whole question that you're going to do on the practice paper is worth 7 marks. So make sure you're picking those up. So far, on the practice paper, it's a little bit of a running total here. We're looking at 3, plus for the percentage question another 3, that's 6 marks. Plus the fraction question is another 2, that's 8 marks. Plus the one we've just looked at, which is calculating 20%, adding it on, 3. Calculating, writing that number as a percentage of the other number, 2. Dividing by 3 times by 8, ridiculous, 2. Another 7 marks. So we're talking about 15 marks so far already on the paper. And the next question is just looking at value for money. So here, what is the best value that you can pick up? Now, the way to calculate value for money questions is just to put them as comparable. Now, you know that if you go to Tesco, and if you haven't, do it. Go to Tesco, go to the drinks aisle, and have a look at the Coke, the Coca-Cola. And what you'll see is you'll see on the ticket that it's got, it doesn't just have the discounts, but it also tells you what the price per litre would be. So what you end up with is you end up being able to compare them, even if they're on sale, with is it better for you to get a 2-litre bottle, or is it better for you to get a pack of 6 cans? What becomes the best value? And it gives you a price per litre. Value for money questions work in exactly the same way. What we're going to do is we're going to give a price per, and we're going to use a unit. In this case, I'm going to do price per gram. So all I'm going to do is I'm going to divide £2.75 by 500. I'm going to divide £3.70 by 650, and I'm going to work out which one's the bigger number, or the smaller number, because whichever one's smaller is the cheapest one, and that's my better value for money. So here, if I do £2.75 and I divide it by 500, comes up with a bit of a ridiculous number, which is 0.0055. So, and then I do £3.70 and I divide that by 650. £3.70 divided by 650 is 0.005692307. And I just need to work out which one's a smaller number. Not which one's a shorter number, but which one's a smaller number. So they're the same, they're the same, they're the same, they're the same. But straight away, that one's a smaller value, so that one's the smaller number. So my better value is coming from 500 grams of sausages for £2.75. The exam you're going to do doesn't even make it that, it makes it even easier than that. Because it sits there and it says a 2 kilogram box of soap powder, a 5 kilogram box of soap powder, and a 9 kilogram box of soap powder. So you're just going to work out how much it costs per kilo. And then compare it. Buy whichever one's cheaper to buy. Done. The next question goes on to rotations. Now when we start talking about rotations, what we're talking about is we're talking about one of our sets of transformations. There are 4 types of transformations. The first we normally talk about is translation, or translate. The second we normally talk about is reflection, or reflect. The third we normally talk about is rotation, or rotate. And the fourth we talk about is enlargement. Now, those four transformations are the mathematical ways that we move shapes around, change things around. And they're used all through the place. They're used in computer games and everything. But what we're looking at here is we're looking at two things. You'll either in the exam be asked to do a type of transformation. So it might say, like it does here, reflect the shaded shape. That'll be the first thing you'll be asked to do. Or the second thing you may be asked to do in an exam is you may be asked to describe the transformation, which means you have to choose which one of these four things has been done to it and give the key bits of information for each. Now there are key bits of information that each of those have to have. For a translation, that's where we slide it around the page. And for a translation, you need a vector. The vector is that thing that looks like this. It might be 2 minus 3, which means it's being moved 2 across to the right and 3 spaces down. You might be asked to reflect, in which case you're given a mirror line, the line that it's reflected in. You may be asked to rotate, in which case when you're asked to rotate, you're given a center, you're given a direction, and you're given an angle. 3 bits of information you need to be able to do a rotation. And the last one is an enlargement. What you're given in an enlargement is you're given a scale factor, and you can be given, and generally to make it more difficult, they'll give a center of enlargement as well, which means it has to be not only enlarged, but enlarges to a specific place on the grid. And so there are 4 different types of transformations. So in this question we're looking at here, what we're going to do is for the first 3, translation, reflection and rotation, you're going to ask for some tracing paper. Straight away on the exam you'll ask for tracing paper. And what you're going to do is, for a reflection, very simple, you not only trace the shape, but you also trace the line that is being reflected in. So in this case, reflect the shaded shape in the y-axis. So there's the y-axis. And then to reflect it, you lift it up and you turn the page over. That's a reflection. The only time you'll pick it up and turn it over is when you reflect a shape. So we put it back down, and you can see there, I can see through there just. So I've got those points, and I draw the shape in and label it T. So that is a reflected shape. The next thing, it says rotate, so I'm using a second one of my skills. So for my second skill, again, you use a piece of tracing paper. You're going to have a look at the second skill. Rotate T 90 degrees anti-clockwise. So anti-clockwise is the opposite direction of the hands of the clock, using 0, 0. So I put my piece of paper on here and trace my shape T. I get my pen, I stick it on the center of enlargement, which is 0, 0 for this case, and I rotate that shape 90 degrees. And you can see where that then goes over. So I then draw that shape on. And I label it U. So now what I've done is I've now reflected and rotated. And the last part of this question is asking us to describe fully the single transformation that will move shape U back onto the shaded shape. So again, for this, get a piece of tracing paper, trace the shape, obviously use the ruler, trace the shape. Now the challenge is to work out how I have to transform this to get it back over the original shape, so the shaded shape. So I start here. Now the first one we look at is, can I translate it? So if I move it up and down and left and right, is there a way that that will look like it sits exactly over the top there? The answer is no. Can I rotate it? So the easiest way to do that, without having to worry about the center of rotation or anything like that, is literally just to hold my shape down, turn it, and see if when I turn it, is there a way so that it will sit in exactly the same way as that one is sitting. And you can see here that that sits back to front. So there's no way I can get it to sit in exactly the same way as that's sitting. So that's not a rotation. It's not enlargement because it's the same size, so it must be a reflection. And in fact, when I pick this up and turn the page over, that's the only way I can get it to sit over the top of the original shaded shape, is by picking it up and turning it over. It's a reflection if I have to turn the paper over. So that has been reflected. Now the challenge is to sit there and work out, I'm just going to remove that to make it easier, work out where the line is. And the best way to do that, I can't do it now, but you can do it in the exam, is to get your piece of paper and turn it so that they're both directly opposite each other horizontally. And then what you'll see that if you did that, a line drawn down there would be the exact reflection of that particular shape. So that's the reflected shape. Now, you need to be able to say, for the marks for this particular question, you need to say, or for any of these really, you need to not only just say which one of the 4 transformations it is, in this case it's a reflection, but you also have to give the key piece of information that goes with it. So if it was a translation, you can say it's translated, but you have to give the vector. If it's a reflection, you say it's reflected, but you have to give the mirror line. If it's a rotation, you say it's rotated, but you have to give the center, the direction, and the angle. And if it's an enlargement, you have to give the scale factor in the center. So I'm going to give the fact that it's a reflection, so I'll write that it's reflected, but I also need to make sure I write the equation of this line. Now you know the equation of this line. The diagonal line going up is y equals x. So the equation of the line going down is y equals minus x. So the answer there is it's reflected in the line y equals minus x. So I've given that line. Just quickly, you should also know that a line that goes vertically down and passes through the x-axis at -2 is just x equals -2. And a line that goes across and passes here through the y-axis at 3 would be y equals 3. You need to know the equations of those basic lines and be able to put them on. Now we're on 15. You're going to pick up 4 marks for doing some value for money questions. That's 19. And here you're asked to describe that transformation, and you get another 3 marks. So we're up to 22 marks so far on the start of this paper. So you should be looking at these and you should be thinking to yourself, you know what, actually, there's quite a few marks to be picked up on this, and you need to make sure these simple skills, these basic skills that you're practicing. Trial and improvement. 4-mark exam question. You're going to go through and you're going to do this. Trial and improvement, simple. It's between 2 and 3. So you should know that the first thing you're going to do is you're going to start with halfway between those, which is 2.5. So x is 2.5. That means x cubed plus 2x, which is 2.5 cubed plus 2 times 2.5. On your calculator, it's calculator paper, 2.5 cubed plus 2 times 2.5. I get 20.625 is too big. I then do it for the number just below that, 2.4. Do it in increments. 2.4 cubed plus 2 times 2.4 is cubed plus 2 times 2.4 is 18.624, which is too small. So I know my answer is either going to be 2.4 or 2.5. So I'm going to go halfway between those and test. So in here, which is 2.45. So 2.45 cubed plus 2 times 2.45 is 19.606125. So, which is too small. So you need to make the decision. Are you going to choose 2.5 or are you going to choose 2.4? It's an easy decision to make because you've got 2.4 was too small, 2.5 is too big, and then when we tested it halfway, we decided that 2.45 was also too small. So I know the answer is going to lie somewhere in here, which means it's obviously closer to 2.5 than it was to 2.4. So that's small and that's big, so it's somewhere in there. So x is 2.5 to 1 decimal place. I'll just write DP to stand for decimal place. Done? 4 marks. So we take our 22, we're now on 26 marks for doing those skills. What is the equation of the line? When I do this, what I'm going to do is I'm going to link this to the idea of sequences, because you can do sequences. So I'm going to write a sequence up first of all. And in fact, what I'm going to do is I'm going to use first value, second value, third value, fourth value, that way. So first value, what I said was 3 in a sequence. The second value was 5. The third value would be 7, 9, 11, and so on. That's a sequence. Now you know how to write the nth term. To do the nth term of this particular sequence, all you do is you have a look and you see what that's changing by each time. In this case, it's changing by 2, positive 2, so that's where we do 2n. And we go back to the 0 term here, which is positive 1, so it's 2n plus 1. That's it. That's sequences, nth term. The thing is, the equation of lines is exactly the same. Exactly the same. So in this case, we're going to write y equals something x plus or minus something. Now, here, what I'm looking at is this first one, and sometimes this is written as y equals mx plus c. It doesn't matter, it just means that this here is the gradient. This here is for every one it goes across, how many does it go up or down? For every one term you go, how many does it go up or down? And this one here is the y-intercept. Now, the y-intercept is just that if I went back 1 to 0, whereabouts does it cut across the y-axis? So line graphs are exactly the same as sequences. So let's have a look at this question. I'm going to sit here and I'm going to say, right, so for this one to here, for every one it goes across, how far does this go up? It goes up plus 2. So that becomes a positive 2, which is 2x. And then here, the y-intercept is where does it cut through the y-axis. So where, when the x term is 0, where when it's the 0 term, does it cut through the y-axis? And in this case, it cuts through at positive 1. So what you end up with is the equation of that line, instead of being 2n plus 1 for the nth term of the sequence, becomes y equals 2x plus 1, but is exactly the same. And you can see that here, the first term would be 3, the second term would be 5, the third term would go up to 7, the fourth term would go up to 9, the fifth term would go up to 11. So sequences and straight line graphs are exactly the same. In fact, in the exam you're going to do, the practice exam, it doesn't even ask for all that. It just asks you for the gradient part of it, or how much it's changing by each time. So if we have a quick look at what the question actually is. Here, it says, find the gradient of the straight line, which is easy. The gradient is for every one that it goes across, so there's 1, how far up is it going? That's all. So it goes across one, how far up does it go? I'm not going to tell you the answer for that, obviously, because that's the challenge you've got to do in the exam. But you can read straight off the graph there. And you get a gradient. You get how far the line's going up or down for every one square it goes across. But a simple jump from that to straight line graphs. And again, once you do that, you write the interpretation, there's another 3 marks. Pythagoras, I'm not going to go into this skill. I'm not, because you guys can do it. You know it's square, square, add, square root. Or, if you're finding the shorter side, it's square, square, subtract, square root. So what we end up with here is we're trying to find the length of the hypotenuse. Square, square, add, square root will give you the length of A. Here, I'm trying to find the length of a shorter side. Square, square, subtract, square root will give you the length of B. Down here, I'm trying to find the length of a shorter side. Square, square, subtract, square root will give you the length of C. In the exam you're going to do, here we go, it hides the Pythagoras question in this rectangle. It says, the diagram shows a rectangle and its diagonals. Work out the total length of the 4 sides of the rectangle and its diagonals. And actually, you can see here, you've got a right angled triangle with Pythagoras. So you can find out the length of the diagonal. Square, square, add, square root. So you've got 2 diagonals at whatever length you just calculated. You've got 39 and 39. You've got 52 and 52. You add them all together, and it gives you the answer for 5 marks for that question. There's another 5 marks that you should be looking at in the exam. The challenge there is obviously seeing that you're using Pythagoras to find out the length of diagonal. Seeing in that shape the right angled triangle, making sure you can see it there. Not ration in problem solving, but ratios in problem solving. Again, ratios are really simple. Just work out the parts that the number's referring to, and away you go. So here, there's 240 pounds in total. In total, there's 5 parts and 3 parts, 8 parts. So 8 parts is 240 pounds. 1 part will be that 240 pounds broken into 8 equal pieces, 240 by 8, which is 30. That means Alice, who gets 5 parts, is 150, and Bill, who gets 3 parts, is 3 times 30, which is 90. There's 60 pounds difference between how much they get. That's your answer. I'm pretty certain that's a pretty straightforward question. Here, 60 pounds in total, 5 parts in total. 5 parts is 60 pounds, 1 part is 12 pounds. Done. 2 parts is 24, 3 parts is 36. Finished. In the exam you're going to do, the practice paper, what you get is, it's a whole long-winded question to be fair. Total number of packages is 4 times the number of parcels. So that means for every 1 parcel, or 4 parcels, you've got, for every 4 packages, you've got 1 parcel. Ratio of 4 to 1. And then I know that those 5 parts there, in total, represent 40 parcels. So 1 part is going to be, well, I'm not going to go through and give you all the answers. You work out what 1 part is, but then you can then work out how many packages you have and how many parcels you have. And then once you know how many packages and parcels you have, the parcels are about 1.5 kilos each. You can work out how much is left for just the packages, and then you can divide that bit that's left by how many packages you have. Done. And just finishing off, graphs of quadratics. We've done straight line graphs before. There's nothing different in this at all. You use your calculator, and on your calculator, 2x squared take away 3x. It's complicated, but it doesn't matter because 2x squared take away 3x is just 2 times, in this case, 3 squared take away 3 times 3. I'll just replace the x's for 3's. Type it in your calculator, push equals, you'll get a value. 2 times 2 squared, take away 3 times 2. 2 times 1 squared, take away 2 times 1. 2 times 0 squared, take away 2 times 0. 2 times minus 1 squared, take away 2 times minus 1. Remember, on your calculator, when you're putting in minus 1, put it in brackets. And then what you'll end up with is you'll end up with a table of values. Plot those points, draw the graph, which is down here. There we go. See, you get a graph on there. The next parts of those questions, all they're asking you to do is they're asking you to read off it. So use your graph to find the value of y when x is 2.3. So when x is 2.3, here's the x-axis, there's 2.3. The value of y, I read off the y-axis, that's it. It says, use your graph to find the value of, to solve 2x squared, take away 3x equals 5. Well, 2x squared, take away 3x equals 5. I go to 5 on the y-axis. 5 on the y-axis. And then I go across and I read those two values off. That's it, done. So you're reading off that graph. On the exam you're going to do, you've got a table to draw. 2 marks for being able to just use a calculator to calculate the values. 2 marks for being able to draw it. And 2 marks for reading off at y is 0. So here, going across and finding out what values it crosses over that line. And again, that's another 6 marks. I'm going to stop there. I'm going to carry on with the next part, in part B. Make sure you revise those and practice them, but if you have a look, you're over 40 marks already on that paper, which is fantastic. Cheers.